In last week's module, we learned about solving systems of equations using substitution, specifically when those equations are already in slope-intercept form. So our learning target for this week is I will be able to solve a system of equations using substitution, even when the equations are written in multiple formats. So we're going to follow very similar steps that we did when we learned about substitution last week, but it's possible that one or more of the equations in our systems is not written in slope-intercept form. And if that's the case, we're going to rewrite or solve one of our equations for either variable. So it could either be x or y. So we're going to dive right in and start doing some examples together. So looking at this first system, y equals negative 3x plus 5 and 5x minus 4y equals negative 3. Remember, when we're trying to solve a system of equations, we're trying to find the point where the lines intersect in the graph, or the point that make both equations true. Okay, so our step one is to solve one of our equations for either x or y. But if I look at this system that I have right now, I already have one equation that's written in the form y equals. So I don't have to do step one. It's already been done for me. So now I'm going to move on to step two. Substitute the expression from step one into the second equation. So I'm going to go ahead and highlight this y, and everything on the right side of the equal sign is equal to y. So what I'm going to do now is I'm going to use substitution to substitute that first equation, or technically the first expression, into the second equation in the place of y. So let me go ahead and show you what I mean by that. And I'm going to make my pen a little bit smaller here. Okay, so I'm going to take everything on the right side of the equal sign here, and I'm going to plug it into the second equation in the place of y. So I'm rewriting the second equation, 5x minus 4, and it says times y, but instead of writing y, I'm going to take that entire expression from the first equation and plug it in, because we know that that is equal to y, equals negative 3. And the reason I did that is because now I have an equation with just one variable, and that variable's x. So I can solve the equation to find what is x equal to. So when I'm following order of operations, I know that I need to do the distributive property. So I'm going to multiply everything inside the parentheses by this negative 4 on the outside. So negative 4 times negative 3x, that's a negative times a negative, so I'm going to write it as plus 12x. And then I'm going to do negative 4 times positive 5. So that's going to be a negative 20, equals negative 3. So that was my first step, doing distributive property. Now I can combine my like terms, 5x and 12x. That's 17x minus 20 equals negative 3. Now I have a two-step equation in which I need to add 20 to both sides. And I get 17x equals 17, because negative 3 plus 20 is 17. My last step to solve for x would be to divide both sides by 17. 17 divided by 17 is 1. 17 divided by 17 on this side is also 1. So I get x is equal to 1. Now, step 4, plug your solution back into the first equation. So now now that I've calculated the value of x to be 1, I'm going to go ahead and plug that back in to my first equation. Negative 3 times 1 plus 5. So negative 3 times 1 is just negative 3. And then if I add the 5, I get y is equal to 2. So remember, your solution is a point. So we're going to write our solution as an ordered pair or a point. Whenever you write a point, you put the x coordinate first and the y coordinate second. So I'm going to write it as 1, 2, which I think is correct, but I'm going to go ahead and check my work by plugging it back into, since I used the first equation to find the value of y, I'm going to plug it back into the second equation to check it. So I get 5x minus 4y equals negative 3. I'm going to plug the 1 in for x, so 5 times 1 minus 4 times 2, because that's the y, is hopefully going to equal negative 3. 5 times 1 is 5. Negative 4 times 2 is negative 8 or minus 8. And I know that 5 minus 8 is negative 3. So thankfully it does check, which means that 1, 2 is my solution. Let's try another example. All right, our two equations are 2x minus 3y equals negative 1 and x equals y plus 1. So I don't have an equation in slope-intercept form, but the nice thing about this one is that it's set up in a way that the second equation is already x equals. So since I already have one of the variables isolated on one side, I am now going to substitute that second expression back into the first equation in the place of x. So basically what I'm going to do here is I'm going to take, let me get my pen, I'm going to take this expression, which is y plus 1, and I'm going to plug it into this first equation in the place of x. That's the substitution part. So I'm going to rewrite it now, and instead of saying 2 times x, I'm going to write it as 2 times the expression y plus 1. Now it's very important that you put that expression in parentheses because you want to multiply everything by 2, not just one of the terms. Okay, I'm going to keep rewriting that equation. Minus 3y equals negative 1. So now, in order to solve my equation to find the value of y, I'm first going to use the distributive property. 2 times y is 2y. 2 times positive 1 is plus 2. Then I get a minus 3y equals negative 1. I'm going to combine my like terms. That's 2y and minus 3y, which is negative 1y, or just negative y, plus the 2 that I already had, equals negative 1. Now I'm going to subtract 2 from both sides, and I get negative y equals negative 3. But I don't want to ever leave a variable with a negative symbol like I have here. So I'm going to go ahead and divide both sides by negative 1 to make that negative symbol cancel out. So then I end up with y equals positive 3. So that's part of my solution. Now I need to figure out the x value because I now have the y value. So when I write my solution as an ordered pair, I have just figured out the y coordinate. So I'm going to go ahead and write the 3 there. But now I need to solve to find the x. So I'm going to, since I used this first equation to help me find the value of y, I'm now going to use the second equation to help me find the value of x. So I'm going to plug in the value that I just got for y, which was 3, and I'm going to add the 1. So I get x is equal to 4. So I think my answer is 4, 3. I'm going to just do a really quick check. I'm going to use the first equation to check. So it's 2x minus 3y equals negative 1. I'm going to put the 4 in for the x, so 2 times 4 minus 3, and I'm going to plug in the 3 for y, and it's hopefully going to give me negative 1, but let's double check. 2 times 4 is 8. Negative 3 times 3 is negative 9, so I'm going to put a minus 9. And then 8 minus 9 is, in fact, negative 1. So thankfully, it does check. which means that 4, 3 is my solution.